If you have not already done so, please download these two worksheets from my Lab Nursing Document Sharing Class 2 downloads. The title goes on. Edit them as you watch the video and be prepared to upload them into the Uploads for Class 2 Dropbox when the video is over and you've completed all of the assignment. Please pause the video and download those if you've not done so. If you've done that, let's continue.
Hello, welcome to your first activity. Today we're going to be making some partial strength solutions. Let's get started.
On your worksheet, you see a diagram of a container that holds 12 fluid ounces when it's full, and it is 1/4 full now. So this 1/4 gray stuff is supposed to represent the solution of Ensure, or the knockoff that I'm going to use in the video. That means that when this is full, 3/4 of the solution will not be Ensure. And usually we use water to dilute solutions. So how many ounces of the solution is Ensure if 1/4 of the 12 ounces is what we're looking at? So 1/4 times 12, 1/4 times 12 will give you 12 divided by 4, or 3. So 3 ounces. And how many ounces of the solution is water? Well, you could do subtraction. 12 minus 3 is 9 ounces, but just to check, is 3/4 times 12? 36 divided by 4? Yes, that is 9 ounces. Please show your work as much as possible. I'm sure your writing will be neater than mine. Because 1/4 of our solution is Ensure, it may be called a quarter strength solution or a 25% solution. But there is a kind of an older way of talking about solutions, and people sometimes use it. You could say that this solution is composed of 1 part Ensure and 3 parts water. So here is where the 1 part comes from, and here is where the 3 parts come from. How many parts are there? There are 4 parts. 1 of them is Ensure, and 3 of them is water. So just be aware of that as we work through this. You'll get a little more practice with that. Let's move this up. All right, now we do not have a 12-ounce solution. We have a 6-ounce solution. 1/4 of it is colored water. The rest is clear water. We're making, again, a quarter strength solution. So how many ounces of colored water are there? This time we're going to be multiplying 1/4 times 6, or 6/4, which, if you divide the numerator and the denominator by 2, you get 3/2, which is equal to 1 1/2. You can express it as, let's express it as 1 1/2 because we're dealing with fractions here. So 1 1/2 ounce of colored water. Of course, that is equal to 1.5 ounces. And how many ounces of clear water? Well, if we subtract 1 1/2 ounces from 6, we should get 4 1/2. But let's go ahead and do the multiplication for practice. If 1/4 is the colored water, then 3/4 of the solution should be the clear water. So this will give us, now another way you can do this is, instead of waiting until the end, like we did over here, to simplify, you could cancel. You could say 2 goes into 4 2 times, 2 goes into 6 3 times. 3 times 3 is 9 divided by 2, and 9/2 is equal to 4 1/2 ounces. 4 1/2 ounces, or 4.5. Now be careful, because I have all of this scratch work done here. When you are looking for clues as to how many parts colored water and how many parts clear water are, don't get lost in all these fractions, okay? The fractions you're going to use are the 1/4 from the original setup of the equation, and whatever the whole minus that quarter is here, the 3/4. So this solution is broken into 4 quarters. 1 part is colored water and 3 parts are clear water. Okay, pause and think about that if you need to. Now let's go on to 10 ounces of solution. 1/4 is chocolate syrup, the rest is milk. This sounds more appetizing to me. Okay, but we're going to deal with it the same way. 1/4 is the chocolate syrup. So 1/4 times 10 over 1. I'm going to go ahead and do my canceling here. 2 goes in here 2 times, 2 goes in here 5 times. So 5 over 2, that's equal to 2 1/2 ounces. 2 1/2 ounces. And how many ounces of milk? Well, if 1/4 is chocolate syrup, 3/4 is milk, and we want 10 ounces of solution. So divide 2 into 4, divide 2 into 10, we get 15 over 2, which is equal to 7 1/2 ounces. And if you add 2 1/2 and 7 1/2, you should get 10 ounces. How many parts of each? Once again, go to your original setup. 1/4, 1 part is chocolate syrup, and then 3 parts is milk. Let's look at example 3. If the volume of solution is 18 ounces, and we want 1/3 cranberry juice, and the rest is iced tea, we're making a third strength solution this time, 1/3 strength. So 1/3 times 18, 3 goes in there 1 time, 3 goes into 18 6 times, so 6 ounces. And 18 minus 6, this should be 12. Let's make sure though, if 1/3 is cranberry juice, 2/3 should be iced tea. This also sounds really good. Okay, 3 goes into 3 once, 3 goes into 18 6 times, 2 times 6 is 12. There we go, 12 ounces. How many parts cranberry juice? 1, because it's 1/3, and 2 parts iced tea, because that's 2/3. All right, number 4. I wonder if this one's going to be as tasty. No. Okay, the solution is 20 ounces. 4/5 is water, 1/10 is potassium, and the rest is sodium. Okay, so 4/5 of this 20-ounce solution is water. So I do some canceling there, and I get 16. So 16 ounces is water. Most of it is water. Okay, but how many ounces of potassium? Well, 1/10 of the solution is potassium. So 10 goes in there 1 time, 10 goes in there 2 times, so 2 ounces. All right, so how many ounces of sodium should there be? Well, 16 plus 2 is 18, and 20 minus 18 is 2. It should be 2 ounces. But when this solution is constructed, what is the sodium strength, or the partial strength of the sodium in the solution? How could we figure that out? Well, let's take a look at our original fractions, because they aren't the same this time. We have 4/5 and we have 1/10. They're a little bit hard to compare, so let's get them into a form where we can compare them. In other words, let's find a common denominator. 10 is a fine common denominator because 4/5 can be multiplied by 1 in the form of 2 over 2 to get 8/10. So we have 8/10 water, 1/10 potassium. How many tenths is sodium is left? 8 plus 1 is 9. That means it's 1/10 sodium. So that's why we also have 2 ounces of sodium, because 1/10 times 20 gives you 2. 2 ounces of sodium. Now, when you're talking about the parts, you also need to have these all in fractions with the same denominator, because this is saying this solution is broken into 10 parts. And you have 8 parts water, 1 part potassium, and 1 part sodium. Let's just move this sheet right on out of the way. Please get ready with your second worksheet. I have sample cans here, well, a sample plastic bottle of a knockoff of Ensure. And we're going to start with that, mixing partial strength solutions. And rather than do multiple takes with me trying to pour this, ta-da, just like a cooking show, I have 1.5 ounces of Ensure ready to go here. It is very hard to see on this scale and in this lighting, but that's 1.5 ounces of Ensure. Why do I have 1.5 ounces of Ensure? Because as you see, our situation is we need to prepare 6 ounces of a 1/4 strength feeding of Ensure. So this is 1/4 of 6 ounces. And the rest of my 6 ounces should be water. And that'll be 3/4 of what I'll be feeding to this patient. So I need to measure out now 4.5 ounces of water. Let's see if I can do this. Hmm. 4.5, 5, 6, 7, 8. It looks like about 4.5. Let's see what happens when we combine them. Did we get 6 ounces? Looks like. Okay, so we have 6 ounces now of a 1/4 strength feeding solution. I wonder. Yeah, it doesn't taste much better than the full strength stuff. But there you have it. So as you're following along on your PDF, you'll see that I chose not to use the clear water and the colored water for this because I had some of this Ensure knockoff available. But what total amount did we see in the mixture? Well, we were making a 6 ounce solution. That's what we made. And if you add 1.5, which is the ounces of Ensure, to 4.5, which is the ounces of water, you should get 6. Is that what we observed? Say yes, even though I was a little bit off. Let's move on to the second situation. Now we're asked to prepare 6 ounces of a half strength feeding of Ensure. Okay, this is going to be done with colored water now. Okay, we want a half strength feeding. So what is 1/2 of 6 ounces? Well, 3 ounces. And we need half of this to be our green Ensure, and we'll need 3 ounces of clear water. So this is going to be a test both of how accurately I can pour and how accurate this measuring cup is compared to this one. So there's my 3 ounces at the top. You can see why I did not choose this measuring cup for the initial measurement. So when you are measuring things, choose wisely. There's no 3 ounces listed here. I would have had to make an approximation. So let's do 3 ounces here. Okay, that's a wee bit too much. Not much though, because we want the bottom of the meniscus to be on the mark. Let's see. And once again, I know that's hard to see, especially when I tip it. Here we go. And let's combine them. So you can see a difference in the color. Slight difference there. It is diluted. And it's at 6 ounces. So this is our half strength Ensure solution. And you can work through the rest of those questions, providing the answers. Say yes, say yes. Now that you've completed your calculations, you can either stop the video again and go prepare your own measuring cups and colored water and practice preparing each mixture. I recommend you do that, or at least you go cook something. But I'm going to prepare 8 ounces now of a quarter strength mixture. And by my calculations, that means that I need 2 ounces of colored water and 6 ounces of clear water to make a quarter strength solution that has a total of 8 ounces. And let's see, I think no, it's about right where it needs to be when it stops moving back and forth. Okay, 2 ounces of my colored water and now 6 ounces of clear. Be careful not to get overconfident there. There we go. All right, and this should be more dilute, lighter colored than before, right? Actually, no. Even though there is more solution, 8 ounces instead of 6, it is still a quarter strength mixture. So there still should not be a terrible amount of difference. You can see some, but the same amount of difference we saw with the 6 ounce quarter strength solution. Let me get rid of that, because now it's time to prepare a half strength solution. So it's going to be half of 8 ounces. So I need 4 ounces of my green water. And 4 ounces of my clear water. Okay, let's see how that goes. 8 ounces, I was a little short on the clear water, but there we have 8 ounces, half strength. Even less of a difference between the colors. All right, so for a 3/4 strength mixture, I need 6 ounces of my dark green water. Ounces and 2 ounces of clear water. Turn it around again so we can all see. Two ounces of clear water. And I have 8 ounces or 1 cup of my solution. There it is. You can complete the table below that based upon what we've done with our 6 ounce solutions and our 8 ounce solutions of different strengths. And then I want to talk you through the conclusions. Let's write a description with parts for a half-strength solution of Ensure. If you have made a half-strength solution of any feeding supplement, you will have half of it to be the feeding supplement and half of it water. No matter what the total volume is, it's always going to be half and half. So I'm going to write in here 1/2 strength feeding supplement plus 1/2 strength water. This solution is in 2 parts. You have 1 part of your feeding solution or Ensure and 1 part of water. So that's what you'd write out there. I'm going to leave that to you. Something very similar to a 1/2 strength solution would be 1 part Ensure and 1 part water. Okay, for a 3/4 strength solution, similarly, you're going to have 3/4 strength feeding solution plus 1/4 H2O. How many parts? You know the answer to that. But I also wanted to emphasize that a half-strength solution is also called a 50% solution, and a 3/4 strength solution may also be called a 75% solution. Please make sure you have completed both pages, all parts of them, and then upload them in document sharing, uploads for class 2, and make sure they are there. If you have any questions, let me know.